What if we lived in a world where the moon and the sun swapped places? Yeah, I know what you're thinking. The consequences would be staggering and catastrophic. But here's an interesting take. What if we somehow survived all this? What would our life look like in such a new world? And what would happen to the solar system? Time to find out. Let's start with the moon. Did you know that the moon is responsible for the tides on Earth? You know, that thing where the ocean goes in and out like it's playing a game of beach volleyball? All thanks to our satellite's gravitational pull. The moon also helps stabilize Earth's rotation. It's pretty important if you don't want to end up like a certain planet that spins on its side, looking at you, Uranus. Plus, it acts as a shield, protecting us from some of the more harmful cosmic rays, asteroids, and space debris. It's like our personal bodyguard. And without our satellite, we might not be here cracking jokes and enjoying life at all. Some scientists think that the moon played a crucial role in the development of life on Earth. Without its gravitational pull, we could have a crazily erratic climate. Also, the moon could have redistributed water across our planet. And we all know that water means life. As for the sun, we all know how important it is. It provides light, heat, and energy for all the planets. But just like any good party host, the sun can sometimes get a little too intense. Never forget that it's an extremely powerful and massive star with a surface temperature of about 37.8 degrees Celsius. If it wasn't for our ozone layer, we would all get burned instantly. The distance between the Earth and the Sun is about 149,668,992 kilometers. Scientists took this distance and turned it into a unit of measurement, 1 astronomical unit, or AU. The closest distance that the Earth could approach the Sun without being completely destroyed is about 0.9 AU. At the same time, if we move too far, further than about 1.2 AU, our planet will turn into a snowball, so we got pretty lucky with our location. Meanwhile, the distance between Earth and the Moon is about 0.002 AU, or 386,242 kilometers. It's super close to us. Now that we know how important these two are and how much their position affects our world, let's try to swap them. Surely nothing bad will come of it. First, let's imagine for a moment that the sun was in the moon's place. You probably already know what will happen to us. The intense heat and radiation from the sun would be like the world's worst sauna, with the temperature on Earth rising rapidly. Any living thing on Earth would leave behind nothing but a pile of ashes. But the destruction wouldn't stop there. The atmosphere and oceans would be stripped away by the solar wind, leaving the planet exposed and vulnerable to the radiation and particles coming from the sun. It would be like a giant space hairdryer on full blast, with Earth's atmosphere and oceans being blown away instantly. Forget about melting ice caps. The entire planet would be one big puddle. But that was a scientifically accurate answer. Boo, boring. Now, what if we could somehow survive this catastrophe? Like, what if we had some super advanced technology to protect us from being fried to crisp? First up, even if our planet somehow survived, things would still get pretty toasty, since the sun would still emit way more heat and energy than the moon. Also, unlike the moon, which goes through periods of darkness during its lunar night, the sun has a constant energy source through nuclear fusion, so at least we wouldn't have to worry about freezing every night. We'd just be sweating buckets in our sleep. Of course, all this extra heat would have some serious effects on our ecosystems. Plants and animals would have to adapt to survive, and we might see some major changes in the way life on Earth operates. Imagine the confusion of nocturnal animals. Without the moon, they would have no idea how to navigate or hunt. So, what would we do in this new, super hot world? Well, maybe we could build some seriously high-tech greenhouses to trap all this heat. Or we could use some giant mirrors or other reflective surfaces to manipulate the amount of sunlight that Earth receives. Next, we have the sun's gravity. Remember how we said that the moon's gravitational pull is just right for stabilizing Earth's orbit? So if we replace it with an entire star, things would get pretty wacky. We're talking about extreme changes in seasons, climate, and all sorts of weather-related shenanigans. Your everyday life would look like it's trying to do the cha-cha slide during an earthquake. The Earth's rotation would also speed up drastically. This means shorter days, longer nights, and lots of confusion with working hours and birthdays. So, is there any way to fix this? Well, hypothetically, we could use some massive spacecraft or other technologies to artificially adjust Earth's orbit and rotation. For example, we could launch rockets or space tugs that would slowly push our planet into a new orbit that's more stable and consistent. And that's not all. All this gravity play would also mean new tidal waves of epic proportions. We're talking waves so high that surfers would need oxygen tanks just to catch a ride. Imagine trying to sail a boat through a hurricane while riding a bucking bronco. Yee-haw! The moon also mixes up nutrients in the ocean and helps support marine life. So if we swap the sun for the moon, those nutrient-rich waters would be a thing of the past. The ocean would become a stagnant, lifeless soup with nothing but algae and plankton to keep us company. We'd have to resort to eating seaweed sandwiches and drinking desalinated water just to survive. And let's be real, nobody wants to live in a world without sushi. So what do we do? Well, we could try to somehow artificially create tides, or mimic the moon's gravitational pull on the ocean, like using pumps or other mechanisms to move large volumes of water around in a way that creates a similar tidal effect. Or we could try to help marine life to adapt to the new, less nutrient-rich ocean, maybe developing fish farming or aquaculture. Finally, don't forget about radiation. The sun is basically a radiation factory. It could seriously mess with our health and electronic devices. You think your phone is fragile now? Imagine what would happen with it under a giant solar flare. So we'd need some seriously advanced shielding technology to protect us. We're talking materials that can withstand temperatures hotter than a jalapeno's backside, and magnetic fields powerful enough to deflect charged particles. Oh, and tons of sunscreen. In summary, if we replace the moon with the sun and somehow manage to avoid catastrophic consequences, it would be a completely different world than what we know. But it wouldn't just be the Earth that would feel these effects. So what would happen to the rest of our solar system? For starters, if the sun with its crazy gravitational pull took the moon's place, it would start seriously messing with the other planets' orbits. They might be sent careening off in random directions like bumper cars. The planets would also have some taste of the sun's fiery personality. They would have to deal with all the radiation and charged particles. Lastly, the sun's magnetic field is incredibly strong, and if it took the moon's place, the other planets would be forced to dance to its tune. This could cause electrical storms, auroras, and other crazy electrical effects everywhere. And what will happen to the moon itself? Unfortunately, its reign in the center of our solar system won't last too long. Most likely, it will either start orbiting the sun and be eaten by it, or simply fly away like a free birdie. So there you have it, a cosmic prank gone horribly wrong. What can we say? Let's just be thankful that such a scenario isn't physically possible, and instead, enjoy the beautiful moon and the life-giving sun from a safe and comfortable distance. Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive, swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon like Mercury. Instead, picture yourself on the surface of a super dynamic, incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees, and at night it becomes terrifyingly cold, down to 290 degrees. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations! You've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecrafts there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So, what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of the Earth. It's even called the Earth's twin. Although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 F, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us: Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars could become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lushier, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we were enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity, and I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year, all because of its strongest gravity, which attracts them all and protects us. But now, our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere, but with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fellow. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of 353 degrees. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face, and the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. Brr! The current Neptune is freezing with an average temperature of about 370 Celsius. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be! That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this, but it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is. No one will hear your cry in space, or something like that. We've all heard this famous chilling phrase, and it's actually true. Space, for the most part, consists of a giant nothingness. There's a lot of, space in space. But this doesn't mean that there are no sounds in space. In fact, there are plenty of them. And some of them can even make you shiver. Let's take a look at the scariest space sounds. First of all, how are cosmic sounds even recorded? Sound is just the vibration of molecules. When you scream, you make the molecules push each other furiously until they reach the ear of the person you're yelling at. Then these vibrations get transmitted to the brain, and we recognize them as something that you might need to apologize for. In other words, to hear something, we need molecules, and that's where things get complicated. There aren't any of them in space. The entire universe almost completely consists of vacuum. No, not a Hoover. Absolute nothingness. However, the wizards from NASA still record space sound somehow. How do they do it? The thing is, there are some types of waves that don't care about molecules. We regular folk can't perceive them without some special devices. These waves include, for example, radio waves. We'll need a radio or something like that to recognize them, and that's exactly what NASA's satellites do. They catch random radio waves. Thanks to their heroism, we can find out how different cosmic bodies sound. These satellites record a variety of waves, fluctuations of plasmas, magnetic fields, and other stuff. And then scientists from NASA transform all this into normal soundtracks. And some of them sound quite frightening, to put it mildly. Let's take our magnetic field, for example. It surrounds our planet like an invisible shield, protecting us from all sorts of nastiness, like radiation or solar winds. At the same time, we can neither see it, nor feel it, nor hear. Oops, the last one is outdated. Scientists from the Technical University of Denmark took magnetic waves recorded by the ESA Swarm satellite. They converted them into an audio track, and got a pretty creepy result. To be honest, it sounds more like an eerie entity stalking you in the middle of the night. And if you remember the maps of the Earth's magnetic field, it starts to feel like a spider crawling nearby. Brr. And this isn't the first strange sound that we caught on Earth. Recently, we caught another weird radio emission from space. Scientists found out that the repeating signal came from somewhere very far away, like billions of light years away from us. Such fast radio bursts usually lasted no longer than a few milliseconds, but this one was unique. It lasted about 3 seconds, basically thousands of times longer than usual. And at the same time, the signal was very precise. So much so that scientists even compared it to a heartbeat. Scientists believe that this signal is caused by pulsars or neutron stars. One time, Nikola Tesla caught something similar. But unfortunately, at that time, we didn't know about such things as pulsars. So Tesla was sure that he had caught a message from some extraterrestrial life. It's a pity that the truth turned out to be much more boring. But let's move on from the Earth to the Moon. In 1969, the astronauts of the Apollo 10 mission, the spacecraft that made the final test flight to the Moon, flew past its surface. And then they caught some strange signals coming from the dark side of the Moon. The side that we never see, because the Moon is tidally locked to us. The sound was so weird that the astronauts weren't even sure whether to report it to NASA. They were afraid that they wouldn't be taken seriously, and maybe even not allowed to participate in the next space missions. Here's what it sounded like. But, according to NASA, it's not some creepy extraterrestrial music at all. These may be just some radio waves that affected each other because of their proximity. Although the astronauts who heard it for the first time probably felt a little creeped out. Let's move to the other planets. 40 years ago, scientists actively explored the surface of Venus. They sent as many as 10 probes there, which were supposed to capture audio and video shooting from the surface. Now we know what Venus, which could easily destroy us at any attempt to even get close to it, sounds like. Horrifying. And you wouldn't expect anything else from the most dangerous planet in the solar system. Unfortunately, Venus is even more toxic than the average Twitter user, so these probes didn't last too long. They heroically arrived on a planet and soon broke down. Next one is Jupiter. This space giant, which is 11 times larger than the Earth, never fails to scare us. One of NASA's probes, Juno, flies around Jupiter every few weeks. The probe is moving at a tremendous speed, 130,000 miles per hour. One day, Juno caught one of the strongest invisible signals it had ever encountered. This was the point at which the mad solar wind came into conflict with the magnetic field of Jupiter. It kinda sounded like a cosmic boom. The original sound lasted 2 hours, but it was compressed to a few seconds. It actually sounds more like a collision of a sea wave with a rock. But here, in terms of horror, Jupiter surprisingly loses to one of its small moons, Ganymede. In 2021, the Galileo space probe flew past Ganymede, and during its flight, it received a rather strange recording. These sounds are satellite radiation, and it's unclear whether it sounds like a cozy sunny day in the jungle or like thousands of bats waiting for you in the night. Next one is Saturn. This signal was caught by the Cassini-Huygens Automatic Interplanetary Station, which was launched into space in 1997. When flying past Saturn, Cassini recorded a pretty scary sound. This terrifying cry of thousands of souls is actually just some radio waves. They aren't too different from what the auroras emit on Earth. A little later, Cassini received another recording, the sounds made by lightning and thunderstorms on Saturn. They sound pretty interesting too. More like popping popcorn or a Geiger counter, right? But that's just because these lightning strikes have a crazy frequency. Moving on from the solar system to outer space. The famous Voyager 1 was launched back in 1977 and continues to send us data even 40 years after its launch. In 2012, it left the solar system and entered interstellar space. And then, while abandoning its home, Voyager 1 detected the sound of plasma waves. The original recording lasted 7 months, but fortunately, scientists felt sorry for us and reduced it to 12 seconds. It isn't really eerie, but is still kind of unsettling. And although it feels like nothing can beat Saturn's horrors, let's end this tournament with one of the scariest objects in the universe, a black hole. This sound was recorded by the Chandra Space Telescope. While studying a cluster of galaxies in the constellation Perseus, they discovered something strange. Some undulating movements appear from the center of the cluster. They spread out in all directions, like circles on the water. Scientists have suggested that this was caused by a supermassive black hole. The thing is, black holes don't always devour space objects entirely. Sometimes they kind of spit them out. This causes vibrations of gases, which we can convert into soundtracks. What's interesting is that the oscillation of each such wave actually lasts about 10 million years. You're just listening to a very accelerated recording. Scientists have reduced the delay between oscillations by about 144 quadrillion times. So, let's check it out. This is probably the eeriest sound from the whole list. Nothing too loud or wild, but there's something dark and disturbing about it. Those were the scariest space sounds captured by NASA. To be fair, most of them sound creepy simply because they're radio waves, but it's still fun to get spooked sometimes. There are a lot of unanswered questions in physics. How did universal energy and matter appear? Where did gravity come from? And much more. We've been trying for years to get answers to these questions, and one of the people who tried to do this was Paramahansa Tiwari, the author of the so-called space vortex theory. What is this theory, and what does it say about the hidden laws of our universe? Let's figure it out. Paramahamsa Tiwari was the former executive director of the Nuclear Power Corporation, India. He took the space vortex theory, or SVT for short, first proposed by René Descartes, and finalized it. He was always inspired by physics and its greats, even since his days as an electrical engineering student. After rigorous study of the laws of physics, he discovered new equations defining matter and the mass and charge of the electron. After that, he came up with the SVT. This theory tried to explain the unexplained phenomena in physics, including the creation of the electron and gravitational, electrostatic, and electromagnetic energy fields, as well as other things. It also described the 6 hidden laws of the universe that underlie our entire world. But first of all, let's talk about the theory itself. Space vortex theory suggests that the universe is made up of vortices, or swirling patterns of energy, and according to SVT, these vortices are the fundamental building blocks of the universe. They're the driving force behind the laws of physics and the fundamental principles of our world. Everything in the universe is connected and interconnected through these vortices. This theory isn't very based on any real observations, but rather on mathematical models and computational modeling. For example, some computational models showed how these vortices work in hydrodynamics and plasma physics. They showed that vortices in such systems can have a central point of attraction and can be interconnected. Other models were used to study how the energies inside the vortices move and how they can create different frequencies and vibrations. But some experts have criticized SVT for using only models and simulations. The biggest criticism is that this theory can't be actually tested. It relies on mathematics and not on some experimental data. That's why it's not accepted as a mainstream scientific theory. But it's still quite interesting and provides a unique perspective on the universe and our understanding of the laws of physics. For example, according to SVT, the universe has some underlying hidden rules that cause the creation of fundamental matter, their assembly, and movement. What are these laws and what do they say? Well, let's take a look at them. Law 1. The universe has only one primordial entity, space, i.e., absolute vacuum, that structures matter. This law states that space is the fundamental building block of the universe, and that it's responsible for structuring matter. It suggests that space is the fundamental entity that creates and maintains the structure of matter, and that all matter in the universe is made up of the same fundamental particles, like electrons and positrons. Let's try to put it in simple words. Imagine that the universe is like a big Lego set. Just like how all the Lego bricks are made up of the same basic building blocks, the universe is made up of the same fundamental building blocks too, and these blocks are called electrons and positrons. But what holds all these blocks together? Space, of course. Space gives it shape and structure, just like how the plastic container holds all the Lego bricks together in a set. So, the first law states that space is the fundamental building block that structures matter and holds everything together in the universe. Law 2. Matter is constituted with multiples of only one kind of fundamental particles, electrons and positrons. This law states that all matter in the universe is made up of the same fundamental particles, the electron and positron. These two are the Lego blocks we've talked about before, and according to the second law, these tiny invisible particles make up everything, from a tiny atom to a giant galaxy. Just like no matter what the shape or size our Lego build is, it's still made up of the same building blocks. Law 3. The field distribution in space, as recognized by contemporary physics, linked with and emanating from matter, are effects arising from only one fundamental field in space. This law states that the fields recognized by contemporary physics, such as the electromagnetic and gravitational fields, are effects arising from a single fundamental field in space. It suggests that this fundamental field is responsible for creating everything that we observe in the universe. So let's try to put it simple. This time, imagine that the universe is like a big playground. All the different fields we observe, such as the gravitational and electromagnetic fields, are like different games we play in there. But no matter what we play, we're still in one fundamental space. This is the playground itself. It's the base that holds everything together. According to the third law, without the playground, we wouldn't be able to play any games. And without this fundamental field in space, we wouldn't be able to observe any fields in the universe. Law 4. There is no void in space anywhere in the whole universe except at the centers of the fundamental particles of matter, electrons and positrons. This law states that there's no truly empty space in the universe, and that all space is filled with the fundamental field, the one we talked about before. It says that electrons and positrons can be found everywhere, and even the things we consider to be empty, like vacuum, are actually full of tiny particles. And according to this law, the only truly empty spaces we can find in the universe are at the centers of the fundamental particles, electrons and positrons. Law V. From only one fundamental universal constant, all the constants, considered universal in contemporary physics, are derivable. This law states that all the constants considered universal in contemporary physics can be derived from a single fundamental universal constant. It suggests that all the constants in physics are interconnected and can be explained by a single fundamental principle. I know you've been doing a lot of imagining lately, but bear with me. This time, please imagine the universe as a big recipe. All the constants in physics, such as the speed of light, the gravitational constant, and the Planck constant, are like the ingredients. They're very different, and there are tons of them. But just like how all the ingredients in a recipe are interconnected and come together to make one dish, all the constants in physics come together to make the universe. And just like how a recipe has a main ingredient that holds everything together, physics also has a single fundamental constant that holds everything together. Law 6. The spatial structure of submicrocosmic fundamental matter is repetitive uniformly in the spatial structures of macrocosmic bodies like planets, stars, and galaxies. This law states that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales, from subatomic particles to macrocosmic bodies like planets, stars, and galaxies. It suggests that the same fundamental principles govern the structure of matter at all scales. Let's go back to the analogy with the recipes and cooking. Using different ingredients and combining them in different ways, the chef can create new dishes. These will all be different dishes, and they can be very simple or very complex. But when creating them, the chef still applies the same basic rules and knowledge they have, right? And just like that, the universe also creates different structures, from atoms to planets, stars, and galaxies. But it still uses the same fundamental principles to create all these things. So this law suggests that the structure of the fundamental particles that make up matter is repetitive and uniform across all scales. These are the 6 fundamental laws of the universe, according to the SVT, and even though it's not accepted by mainstream science, it's still a pretty interesting concept. Imagine a universe made of antimatter. In this alternate reality, the building blocks of matter are made up of particles with opposite charges, creating a strange and wondrous world. What would it look like? Would the laws of physics be inverted? Would time run backwards? Buckle up and let's find out. First off, let's figure out what antimatter is. We know that our universe is composed of matter. Matter is made up of tiny particles called atoms. These atoms are made up of protons, neutrons, and electrons, which together form matter and make up everything around us and what we're all made of. Antimatter, on the other hand, is just like regular matter, but the opposite. Just like how superheroes have opposite powers from their villains, antimatter has opposite properties from regular matter. So while regular matter has protons with positive charges, antimatter has antiprotons with negative charges. Instead of electrons, we have positrons, and instead of neutrinos, we have antineutrinos. It's like the mirror image of everything we're familiar with. Now, here's an interesting part. When an antimatter particle and a matter particle collide, they annihilate each other and release a huge amount of energy. This is both a benefit and a drawback. On one hand, because of this property, studying antimatter is very difficult and expensive. We have to be very careful to ensure that antiparticles don't come into contact with ordinary atoms and don't annihilate each other. On the other hand, the huge amount of energy they release could revolutionize our lives. Perhaps one day, we'll start using them in propulsion systems for space travel. Imagine how amazing that would be. Scientists suggest that at the beginning of the creation of our universe, immediately after the Big Bang, matter and antimatter were equal. But this raises the question, where did the antimatter go? If they were truly equal, our universe would have been instantly destroyed before it could even be formed. Particles and antiparticles would have annihilated each other. Unfortunately, scientists themselves are not sure. They have a theory that the laws of physics were slightly different in the early universe, leading to an imbalance between matter and antimatter. So, after the Big Bang, particles and antiparticles began to mutually annihilate each other. However, for some reason, antimatter started to disappear. In the end, matter won. This process led to the creation of our universe. In the science world, it's known as baryogenesis. However, there are also scientists who offer more grandiose ideas. For example, a team of Canadian scientists from the Perimeter Institute for Theoretical Physics, led by Neil Turok, have proposed their own theory. They suggest that two universes were born at the moment of the Big Bang, our universe and a parallel one, consisting of antimatter. This is where all the antimatter has gone. According to this theory, at the time of the Big Bang, two universes were born, and then they separated. As the distance between these universes grew, the interaction between particles and antiparticles became weaker and weaker, until matter won in our universe and antimatter in the other. But the most important question is, what would this mysterious universe made up of antimatter look like? You may imagine a universe where everything is flipped. The stars shine with an eerie blue light instead of yellow. Buildings are made of glass that reflects light in the opposite direction. And laws of physics work in the opposite way. After all, antimatter has the opposite charge of normal matter, so isn't that logical? However, it's not that simple. Initially, scientists believed that this universe would be identical to ours in everything, all due to a property that used to be known as CP symmetry. The C stands for charge symmetry and means that each elementary particle has a twin with an opposite charge. The P stands for parity symmetry, meaning the symmetry of space. That is, all three directions in our world have opposite directions in the alternative universe. This basically means something like, laws of physics are the same no matter what the location is and what type of particle is being considered. So if you were to run the laws of physics in reverse, or in a different location, or with different particles, the results should be the same. In simple words, scientists initially assumed that the universe of antimatter would be a mirror image of ours. It would be a pretty boring world where everything would be exactly the same as here. But in the 1950s, scientists were mind-blown by an unexpected discovery. Neither of these symmetries held true. For example, if you take a piece of cobalt-60, it will emit particles that spin in one direction. But if you take the opposite of cobalt-60, the particles it emits will spin in the opposite direction, but they were expected to spin in the same direction. So what's going on here? Basically, it turned out that CP symmetry didn't work for certain weak nuclear reactions. The weak nuclear force is just weird like that, I suppose. This observation puzzled scientists for years. And then they finally figured out how to solve this mystery. They added another letter to CP symmetry, T, which stands for time reversal symmetry. This means that in the antimatter universe, time must flow from the future to the past. In this case, the CPT property held true, so it turns out that the antimatter universe would be a mirror image of our universe, but with time flowing in the opposite direction. So there may be a version of you in this verse, watching this video on your upside-down computer, already knowing the ending. Isn't that crazy? So although this universe would look similar to ours, it would also be fundamentally different. In this world, things would unravel instead of coming together. For example, broken objects would come back together to form whole objects. people would age in reverse like Benjamin Button, and apples would fly up from Newton's head back to the tree. This, of course, is all purely hypothetical. It's very difficult for us to imagine a world where time flows backwards. We can only imagine how surreal this inverted reality would look like. But this is what the data suggests for now. There might be something we don't know yet that would make the antimatter world different. But as far as we know today, it seems this is what a mirror world made of antimatter would look like. Scientists are still studying antimatter and its properties. Understanding these properties is important for a number of reasons. First of all, it gives us a better understanding of the universe and its origins. The imbalance between matter and antimatter in our world is one of the biggest mysteries in physics. Studying antimatter can help us understand why this is the case. Second, it would give us a better understanding of particle physics and subatomic particles. This knowledge can help us unlock the secrets of the universe and make new discoveries in physics. And of course, let's not forget about all the possible technological advancements. Antimatter has the potential to be used as a source of fuel for future space missions and other technologies. We could use this in propulsion systems to travel from planet to planet. We could also use antimatter in medicine, for example, for cancer treatment. Also, in medical imaging, antimatter particles can be used to produce high-resolution images of the inside of the body, giving doctors a better view of what's going on. So, in other words, understanding the properties of antimatter is very important for science. It's a fascinating field of study that has the potential to unlock some of the biggest secrets in the universe. A universe made of antimatter would be a fascinating place. It would be very interesting to visit there and see how everything works. And the true nature of an antimatter universe remains a mystery, waiting to be explored and understood. But let's hope that we'll figure these mysteries out in the future. Let's see, there's Mercury, Venus, Earth, Mars, Phaeton, Jupiter. Hold on, what? What Phaeton am I talking about? Well, let's see. It was the beginning of the 19th century, and the asteroid belt hadn't been discovered yet. In the year 1801, one man called Giuseppe Piazzi spotted the largest asteroid in the solar system, Ceres. At that time, people believed that there was a planet orbiting between Mars and Jupiter, and Ceres seemed to fit the bill. But the next year, another astronomer, Heinrich Olbers, found one more space body following a similar orbit. It was an asteroid which was later called Pallas. This discovery helped Olbers to figure out that these two space objects could be fragments of a planet. The discovery of two more asteroids, Vesta and Juno, seemed to confirm this theory. It was believed that the planet, which was named Phaeton in the 20th century, appeared in the early days of the solar system and was later destroyed, and its debris formed the asteroid belt. Olbers' idea was called the disruption theory. To astronomers of that time, it seemed obvious that the planet once collided with a large space object, which led to its demise. The most likely candidate was Nemesis, a hypothetical red or brown dwarf orbiting our sun. Another theory claimed that Phaeton could have gone through an internal cataclysm, which could have broken the planet into pieces. There was one more idea. Phaeton could have come too close to Jupiter and got torn apart by the gas giant's immense gravity. These days, though, astronomers don't believe in the disruption theory anymore. A new idea has replaced it. It's known as the accretion theory. It claims that the asteroid belt is all that is left of the protoplanetary disk. Supposedly, this disk had been originally orbiting the sun, even before the planets formed. Unfortunately, because of Jupiter's gravitational forces, it never managed to coalesce into a planet. But what is this asteroid belt we keep talking about? This region is located between the orbits of Jupiter and Mars. Tons of asteroids and even minor planets are found there. Some of them can sometimes migrate or get thrown out of the asteroid belt to the outer solar system. The four largest asteroids in that area are Ceres, Vesta, Pallas, and Hygeia. They make up half the mass of the entire belt. As for the rest of the mass, countless smaller bodies make up for it. In loads of sci-fi movies about space, the main character gets into an asteroid belt and has to try hard to get away from countless rocks, threatening to smash their spacecraft. Well, it has nothing to do with the real thing. Even though there are thousands of asteroids in this region, they're so widely spaced that the chance of collision is next to nothing. Hey, but it's a movie, right? Anyway, when the asteroid belt was forming, some objects started to come together and form what we know as protoplanets. But the gravitational pull that was caused by the formation of Jupiter made such collisions too rough, and instead of forming large space bodies, like planets, asteroids shuddered. Astronomers think that as a result of such collisions, more than 99.99% of the original mass of the asteroid belt was lost in the first 100 million years of the history of the solar system. Only the largest asteroids have enough gravity to get a spherical shape. Smaller ones are often just piles of rubble loosely held together by gravity, and the tiniest objects in the asteroid belt resemble dust, so small they are, and all these objects, giant and tiny, orbit the sun. There are several types of asteroids depending on their composition and albedo, which is the proportion of light or radiation reflected by a surface. The main types are carbon asteroids, which have a very dark surface. Silicon ones, you can also call them stone asteroids, and metal ones. The first two types account for around 75% and 17% of asteroids we know about. For the first time, the asteroid belt was crossed by a spacecraft in 1972. It was the Pioneer 10 space probe. The spaceship managed to refute the theory that the belt was filled with dust that could easily damage all gadgets on board. It didn't happen, and since that time, 8 more probes have traveled through the asteroid belt. And now, I'm about to tell you some cool facts about the solar system itself. Try to count how many of these facts you've known before, and write your answer down in the comments below. The solar system is a staggering 4.5 billion years old. Scientists came to this conclusion after studying meteorites, the oldest material they managed to find. But our solar system isn't the only one in the Milky Way galaxy. The galaxy we live in houses about 100 billion star systems, and if it's just our galaxy alone, what can we say about the whole universe? Our sun is also insanely massive. Here's some proof. 99.86% of all the mass of the solar system is the mass of the sun, in particular, hydrogen and helium it's made of. The remaining 0.114% is mostly the mass of the solar system's 8 planets. By the way, contrary to popular misconception, outer space isn't a perfect vacuum. It contains not only stars and planets, but also clouds of interstellar dust, space plasma, and cosmic rays. Those are atom fragments dashing from the outskirts of the solar system. One phenomenon astronauts should worry about while exploring space is cold welding. If 2 pieces of the same kind of metal touch in space, they bond and get permanently stuck together. Kinda like galaxy glue. It doesn't happen on Earth since water and air keep pieces separate. You can see solar eclipses because even though the moon is 400 times smaller than the sun, it's also 400 times closer to Earth, so it's perfectly capable of obscuring the star. But in 600 million years, the moon won't be able to block the sun completely because of the satellite's changing orbit. Behind the orbit of Neptune, there is the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed. Or not. The ocean on Jupiter is larger than any body of water on other planets of the solar system. But it's not the ocean you think about. The one on Jupiter isn't made of water. This mesmerizing thing consists of metallic hydrogen, and its depth is around 40,000 kilometers, which is actually almost the same as the circumference of Earth. People got to know about beautiful Saturn's rings in the 1600s, but now we know that Saturn isn't the only ringed planet. All the giant gas planets, Uranus, Neptune, and Jupiter, have rings of their own, but they are thin and almost impossible to see. As for Mars, Venus, and Earth, they are made of rocky materials and have no rings. At the same time, Saturn's moon Rhea might have a ring system consisting of 3 narrow bands. If astronomers manage to confirm it, it'll be the first time for people to discover rings around a moon. Oh, and Mars might get a set of rings of its own in the next 70 million years. The red planet's largest moon, called Phobos, is orbiting closer and closer to the planet. One day, it's likely to get broken apart by the gravitational pull of the red planet and turn into a ring that can last for millions of years. And another cool fact about Mars. You've probably heard of methane gas, a byproduct of such natural processes as volcanic activity and cow emissions. Anyway, this gas is not only a part of the Martian atmosphere, but also the thing that confuses astronomers to no end. The thing is that the volume of methane on Mars keeps wavering, and scientists just can't figure out where it might be coming from. Can there be life on Mars? Can there be cows on Mars? It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? See, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hanson, 1996, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam! Everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter Theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh? Imagine a still frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms, all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peak structure, or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation, battering the satellite's surface, which, in turn, increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years, and then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true, and they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium, due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen. For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus? Totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed, and it had to make scientists suspicious. But they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere, or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth. An object weighing billions of times the mass of our sun must be easy to find, right? Wrong. Unfortunately, it might not be that simple, like in the case with a missing black hole. But let's travel to the galaxy cluster Able 2261, hosting a supermassive black hole at its center. Or at least, that's where it's supposed to be. The main problem is this giant space phenomenon is nowhere to be found. Now, supermassive black holes are mega monsters, churning slowly at the centers of their home galaxies. They gather tremendous clouds of gas and dust around them, which makes them swell up to sizes the human mind can't begin to imagine. If a supermassive black hole, like the one that dwells at the center of our home Milky Way galaxy, moved even a bit closer to our solar system, we'd be doomed. The distance between this huge thing and Earth could be several dozens of light years, and still, it would wreak havoc on our planet. Earth, along with other things making up the solar system, would be tugged into the black hole's orbit and doomed to spin around it for eternity or longer. Hey, who knows, right? So it's good that such black holes stay away from us at the moment. So, let's see what's happened with that runaway supermassive black hole from that gigantic cluster of galaxies around 2.7 billion years away from our planet. Scientists have been looking for it with the help of NASA's Chandra X-ray Observatory and Hubble Space Telescope, but so far, no result. The main problem with finding a black hole is that it's, black, and space is, you guessed it, black too. So there's no contrast whatsoever that could help astronomers spot the hole, but scientists haven't given up yet. After all, they have a lot of other technologies to find black holes, small and big, in the vastness of space. Some of these methods involve watching the stars orbiting black holes. Sometimes it's a faint gravitational wave signal, which is produced when two black holes collide, but the most reliable technique is watching dust and gas falling to their doom. The thing is, black holes are space objects with insane gravity, so regions of space surrounding them are usually a bit chaotic, gas and dust getting pulled into the bottomless abyss, compressing and heating up. In the process, it releases a flood of X-ray radiation, so astronomers look for extremely bright X-ray sources in the universe. Chances are, those are the last gasps of giant clumps of material before they disappear into a black hole. Then why can't scientists find such X-ray signatures left by the black hole in Able 2261? One of the most mysterious things about its disappearance is that radio telescopes have spotted some signs of massive plumes of superheated material, launched at one point within the last 50 million years. These plumes were most likely caused by a large black hole, which is nowhere to be found these days. So, at the moment, we can only play a guessing game. Maybe two medium-sized black holes collided, pushing the newly merged giant out of the center of the galaxy. The observations of the stars in that galaxy have shown a clump of dense material a few thousand light years away from the galaxy's core. Maybe it's the runaway black hole, but disappointingly, no X-ray signals are coming from that clump. Or the hole might still be there, in its rightful place, but it's, slumbering. If it doesn't get a fresh supply of gas and dust, it has nothing to feed on. As a result, it can't release a flood of X-rays. But again, the answer, do not disturb, the black hole is sleeping now, isn't very satisfying. Why isn't it getting its space food? What happened 50 million years ago? What is that clump of material speeding away from the galaxy center? So many questions and no answers so far. At least we know what black holes look like. Well, kinda. It's actually the shadow of a black hole's event horizon visible against the glowing superheated material falling inside the hole. The first ever mugshot of a black hole appeared in 2019, but the data for its creation was collected in 2017. It took an international team consisting of more than 200 astronomers 2 years to assemble the image. We can admire this amazing space phenomenon thanks to a vast global network of telescopes called the Event Horizon Telescope Collaboration, or simply EHT. Why such a name? The thing is that the event horizon is a point of no return on the outskirts of a black hole. Once something, for example, matter, radiation, or light, reaches this boundary, there is no way for it to escape the black hole's clutches. Anyway, to capture the very first image of a black hole, scientists created a virtual telescope that turned out as big as our planet by combining the power of 8 powerful radio telescopes. But it wasn't an easy feat. The researchers had to simultaneously point the telescopes in a meticulously planned order with the help of precise atomic clocks set on each telescope. Plus, to keep the chances of rain and bad weather to a minimum, they even constructed the telescopes in super dry regions, such as the Atacama Desert in Chile and the South Pole. On each observation day, the telescope gathers roughly 350 terabytes of data. That's 10 times the amount of data collected every day at the Large Hadron Collider. But let's speak more about black holes themselves. There are stellar black holes, smaller but even more dangerous than their supermassive peers. They appear when stars that have run out of their star food fall into themselves. If a star used to be big enough, it keeps compressing and compressing some more, and voila, a baby stellar black hole is born. But even if I call such a hole a small one, it's still 5 to several tens of times heavier than the sun. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 SUVs. One theory claims tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. There is a supermassive black hole smack dab in the middle of our galaxy, the Milky Way. Its name is Sagittarius A, and it's 4.3 million times as heavy as the Sun. And nope, we aren't going to be pulled into this hole. It's more than 26,000 light years away from Earth, too far to have any influence on our planet. By the way, recently, astronomers have discovered that this supermassive black hole might be leaking. If it's true, it probably means that Sagittarius A isn't a sleeping giant. As previously thought, it might still be active, and the leakage recorded by scientists may be the hole hiccuping while swallowing clouds of gas. Maybe we should burp this baby? If you ever find yourself near a black hole, get ready that the time will significantly slow down. It may work for you if you aren't eager to grow older. Just don't let yourself be tugged behind the point of no return. Another danger of hanging around a black hole is that it might start behaving like a massive galactic volcano. From time to time, black holes flare up, but instead of spewing lava, they produce enormous amounts of energy, and it makes gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light years away from Earth. The crater left behind, which was actually a hole punched in the cluster's hot gas, could fit 15 Milky Way galaxies. Okay, mind blown. I'm out of here.
So here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard of black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies. 2 of them, located 9 billion light years away from Earth, are expected to collapse into each other, and oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. By the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very slow. I'm talking billions and billions of years before a black hole loses its mass entirely. That happens because they are constantly losing their mass, every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that 2 black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? Now. No need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, SDSS J1430 Plo2303, but let's just call it Super Far Away Galaxy. You might be asking yourself, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently, the PKS 2131021, long name, but let's just call it Andy. Imagine you're a scientist at Caltech, and you're looking at a blazar in your radio telescope, and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy, but then you realize that there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer, and the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our sun. Have you seen our sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. This is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light, but we weren't really affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies. And they will reach the solar system. But what is this shockwave actually capable of doing? It could stop our sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, the blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat. We'd all turn into tiny particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, plants, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It is always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including me, you, your cat, and our planet, creates a warp or distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely differently for astronauts on long missions and for people that remain on Earth. And this is why a collision of two megablazars could mess with our perceptions of space and time. due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that interstellar scene, right? Where the lead character bends the space-time continuum through a black hole. Don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazer explosion will happen in approximately 10,000 years. But wait a minute, if this blazer lies 9 billion light years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born just around 4 billion years ago, and since it takes us 9 billion light years to receive the light emitted from the blazers in the first place, this means that the collapse of the two blazars already took place, and that it will reach Earth 10,000 years from now. This means the shockwaves are already making their way through the galaxies at this very moment. But still, it's something not even your great-great-great-great-great-grandchildren will be around to see.
A recent study has involved almost 200 huge stars that are reaching the end of their lives. It has given scientists more precise information about how the sun will one day end. It turns out that the sun will be about 200-300 times bigger than it is now by the time its game is over. For starters, let's begin with some basic information about star sizes. Giant ones reach this stage because they've run out of nuclear fuel and are no longer burning hydrogen in their core. Eventually, the core gets hot enough to trigger the next stage of fusion, which is helium burning. All the stars that were surveyed in this new study were either in this hydrogen shell burning or helium core burning phase. Even though giant and supergiant stars only make up less than 5% of all stars, or at least that we know of, they're actually really visible from a distance because they're so bright. In fact, according to scientists, about 1/3 of all the stars you can see outside on a dark moonless night are giant or supergiant stars. This study will eventually give astronomers really useful info about massive stars. They'll be able to figure out their size and temperature, no matter where they are or their evolutionary stage. This means they can see a star's true color and use that to find out its radius. Pretty cool, right? It does raise the question, what will our sun be like when it gets old and grumpy? To put it simply, it will expand when it starts burning its hydrogen shell, but then shrink a bit during its helium core burning phase. After a few 100 million years, it'll end up as a giant star about 200 to 300 times its current size. Eventually, the sun will expand so much that it will simply evaporate. So, what will happen after the sun fades away? Scientists actually have some predictions about what will go down, even though we won't be around to see it. They're pretty sure the sun will turn into a planetary nebula. These planetary nebulae are chunks of gas and dust in space that come from a star that is fading away. They got their name because they looked like planets to people using telescopes back in the 18th century, even though we now know they have nothing to do with actual planets. But here's the crazy thing. Astronomers have found out they can use the level of brightness of these planetary nebulae to calculate their distance from us. In 2018, scientists also found out that the sun is the smallest a star can be to still be able to produce a visible nebula. Any smaller, and it would not be visible. Stars that are up to 3 times more massive than the sun will produce brighter nebulae. The sun is currently 4.6 billion years old, but it's estimated to have another 10 billion years until its end. The sun is also getting brighter with each year. It doesn't seem like a lot now, but it's actually going to cause some big problems for Earth. In about 1 billion years, the sun will be too bright for life on Earth to survive. Our oceans will evaporate, and it will be too hot for water to form again. So, unless we find a way to escape from this planet, humanity only has about 1 billion years left. Will Earth still be around by the time the sun turns to dust? It's hard to know for sure the exact timeline, but even before that happens, Earth will most likely be scorched and lifeless, with no atmosphere or oceans left. It's not clear how close the sun's outer layers will get to Earth, but if they get too close, it could cause Earth to spiral into the sun and disappear altogether. Even if our planet does somehow manage to survive the sun's giant phase, it will be orbiting a hot white dwarf, or a star that has run out of its fuel. In that distant future, the sun will be barely larger than our planet. Eventually, the sun will cool and dim completely. It'll move to another stage called a black dwarf. It will cause Earth's orbit to loosen up, and our planet will spiral into the faded sun. But interestingly, the sun doesn't get the final say in what happens to Earth. Gravity keeps planets in orbit, but it also attracts them to each other, which can cause their orbits to flex and drift. This could lead to the solar system destabilizing and ejecting planets, including Earth. Basically, a lot might happen in the next 5 billion years before the sun becomes a red giant. There's also another scenario. While most stars stay far away from our solar system, there's a chance that one could come closer in the next billion years. Even a small star or black hole could mess up the orbit of our planet if it gets too close. But don't worry too much. The odds of that happening are low because of the amount of space between stars. Our sun is a solitary star, so there's little to no chance we'll be able to catch a ride with another one nearby. However, many stars in our universe have companions. Among these stars is Castor, a stunning system that comprises 6 stars and is one of the brightest objects in the night sky. Although humans have been admiring Castor for ages, they were not aware of its true nature until the invention of telescopes and spectroscopes. Even with the help of a small telescope, it's evident that Castor is composed of 2 primary stars, Castor Aya and Ba, that revolve around each other. These stars are larger than the Sun and need 467 years to complete one orbit. In total, Castor is composed of 6 different stars. The biggest one, called Castor Aya, is roughly 2 times larger than the Sun, while the smallest has about 0.5 of the Sun's mass. If humans want to survive the next billions of years, we might need to set up camp somewhere else in the universe. It may seem like something out of a sci-fi movie, but it could be our reality one day. Thankfully, NASA is already looking at some options. They've discovered 2 new planets, TOI 700e and TOI 700d, that might be new hotspots for us humans. TOI 700e is in the optimistic zone, which means it could have water and even an atmosphere. TOI 700d is in the conservative habitable zone, so scientists aren't too sure about it yet. But hey, we'll take what we can get. But hold on. Before you start packing your bags, there's a little problem. How do we get there? It took John Glenn months of preparation just to circle Earth 3 times, so we might need to start working on our astronaut training. Well, at least we have some options for our future intergalactic vacation plans. Wouldn't it be nice if we could time travel so we could see what our solar system will look like in billions of years? An American physicist named Ron Mallett has proposed one interesting theory for time travel. It uses light, a resource that is abundant in the universe. His idea involves using a rotating cylinder of light, which could transport an object in both space and time, similar to how a bubble moves in a swirling liquid. Mallett suggests that a cylinder of the right shape could allow for travel to the past and the future. To test his theory, he has been trying to secure funding for an experiment. However, some scientists consider Mallett's theory to be impossible and unnecessary to test. We might also be able to travel through time if we move fast enough. According to Einstein, the way we experience time can change depending on how fast we're moving. If we go really fast, time slows down. For example, astronauts in space age a tiny bit more slowly than people on Earth. This is important for things like GPS, which would be incorrect without special adjustments because of how time is affected. You get the last instructions from the team and get into your spaceship. It's the first spacecraft made on Earth that can move at a speed close to the speed of light. Your task is to visit the most unusual and terrifying places in space and send scientists detailed information about them. And so your journey begins. Your spacecraft is accelerating, and you dash past the moon. In the distance, you see a small reddish planet. It's Mars. And look at that spectacular giant surrounded by a set of rings. That's Saturn. You wish you could have more time to explore this gas giant, but you have to hurry. You pass by beautiful stars. Some of them are luminous, others have a reddish hue, and some seem to be dimming. That's Sirius, the brightest star in the night sky on Earth. It's about 8.6 light years away from us, but you're traveling fast, and soon you see Polaris, aka the North Star, which is way further. 431 light years away. Sometimes you manage to spot tiny dots circling these stars. Those are planets, and then suddenly you see nothing. At first, you're horrified. Has something gone wrong and you've accidentally entered a black hole? Has your equipment malfunctioned? Because it seems that at a distance of 700 million light years away from Earth, there's a hole. A blank void with no galaxies, stars, planets, or asteroids. You can see nothing. The void is a roughly spherical region about 330 million light years across. Our home Milky Way galaxy could fit there billions of times over. And then it dawns on you. What you're looking at is the mysterious Bode's Void. It lies about 700 million light years away from Earth in the constellation of Botas, the herdsman driving the plow around the North Pole. At first, this void was called the Great Nothing, but later it was given its current name. Now we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are ginormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light years wide. The Bode's Void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. But what could have caused such giant empty areas to appear in the first place? The reason might lie in the origin of the universe. In its early days, all the matter in the universe was packed together quite tightly. Astronomers even think it was something like a uniform soup. But pretty soon, random quantum fluctuations started distributing this matter. Some areas became denser. As a result, their gravitational pull became stronger, and they began stealing matter from less dense regions. This made such areas even denser, and they kept attracting more and more matter. At the same time, smaller clumps of matter started drifting further away from the center, forming galaxies. After staring at nothingness for some time, you decide to explore other space objects and start the engine of your spacecraft again. There's one kind of space formation you've been looking forward to seeing: nebulas. Those are gigantic clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. Sounds familiar, doesn't it? One day, this mass becomes so big that it collapses under its own gravity and forms new stars. So you decide to visit some of the most beautiful nebulas out there. And you start with the Butterfly Nebula. This butterfly's wingspan is more than 3 light years. And the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 250,000 HRC. It means it was formed from a gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass or a butterfly. The next place you decide to visit is the Eskimo Nebula, 5,000 light-years away from Earth in the constellation of Gemini. It was discovered more than 200 years ago and got its name for a reason. Its double shell formation looks like a person's face, hidden in a padded hood of a winter jacket. But in reality, this parka is a disk of material with a ring of comet-shaped objects. And the tails of these objects stream away from the star at the center of the Eskimo Nebula. The bizarre orange streaks in the outer part of the cloud stretch light years away in all directions. As for the Eskimo's face, even though it resembles a ball of twine, in reality, it's a bubble of material blown into space by the wind of high-speed material produced by the central star. Your next destination is the Ring Nebula. At first sight, it's a giant cloud of dust and gas surrounding an old, almost extinguished star, which does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. The deep space colorful object more than 2,000 light-years away from Earth is actually a ring that wraps around a blue, ball-shaped structure. Each end of this structure sticks out of the ring's opposite sides. Now, you can head to a place called the Pillars of Creation. You find it more than 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old, space babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called Pillars of Creation, an active star-forming region. And since you've already visited a star-forming region, why don't you drop by a living fossil galaxy? For example, at Sassii, it's as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It can mean that DGSat I was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true the galaxy is a real living fossil, the next stop on your space sightseeing tour is the Black Widow pulsar. Just like its spider namesake, this rotating neutron star, J1311 3SFAR 3, is munching on its partner, a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. Oh, look at this! That's a stellar nursery in the constellation of Centaurus. But even though this place might be called nursery, it's anything but peaceful or safe. This region, made up of hydrogen and newborn stars, is located in a nebula in the constellation of Centaurus, around 6,500 light-years away from Earth. The intense energy these baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful that it's eating away dark clouds of dust, and they're disappearing like lumps of butter on a hot frying pan. You're continuing your journey when you see something absolutely amazing, a cloud of water floating in space. To be more precise, it's a cloud of water vapor surrounding a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements, and gathering data about the planet for more than 10 years, 2011. And good old curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kinda expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now. A spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 2 meters long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic looking and dark gray. It's rounded and smooth too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with lighter colored material surrounding them. And the cool thing is, these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way that winds blow. But back to our buddy Curiosity. It has been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why though. And of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. This doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of it a long time ago. Curiosity discovered potential evidence. There might be a large reservoir of liquid water beneath the South Polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts, perchlorates in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. It's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So you never know, there might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time, and one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars' atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient megaflood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
Imagine a still frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the sixth satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms, all because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space.
Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peak structure, or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa, and scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation, battering the satellite's surface, which, in turn, increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years, and then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true, and they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium, due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus? Totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed, and it had to make scientists suspicious. But they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere, or even if there was, it was a very small amount. So far, we need